Hi, welcome to my channel. In the previous video, we discussed about the main challenge of the machine learning. So, in this video, we are going to see one of the main challenges of the machine learning is non-representative training data. Non-representative training data. So, non-representative training data refers to a data set that does not accurately reflect the true, true distribution of examples in the real world. So this can lead to bias the models and poor generation to new or unseen data. It ensuring the training data is essential for developing a robust and fair machine learning models. So that means in order to develop a best model for the machine learning, we require the you have to require all the training data. So non-representative training data can occur for based on the different reasons like data collection bias, imbalanced class distributions, and sampling errors. Based on these things, we are unable to represent all the training data. So, some common occurrences like selection bias. Selection bias when the certain data samples are over represented and are underrepresented. Overrepresented and underrepresented. Due to this, the method of data collection or sampling. Due to this one, we are unable to get the better result. Bias is nothing but the actual output. There is some variation between the actual output and predicted output. This is because of over representing the data or under representing the data. So there are some other common occurrences like imbalanced classes. In classification task, one class may have significantly fewer examples than other, that leading to the model to favor the majority class and perform poorly on the minority class. So in order to predict the model in the classification models, you have to represent all the features in a equal distribution of the data. And concept drift. Over the time, the distribution of real world data may change, but the training data remains static. It causes the model to become less accurate. And to overcome this problem, non-representative training data, you have to follow different strategies like diverse data collection. It ensures your training data set covers a wide range of scenarios and represent the target population fairly. This is the major thing we have to overcome the non-representative training data. And second one is random sampling. Use the random sampling technique to minimize the selection bias and ensure the more representative data set. And third one is class balancing. If dealing with imbalanced classes, use the techniques like oversampling, undersampling, or generating the synthetic examples to balance the class distribution. And the fourth one is continuous monitoring the data set. Regularly update and monitor the training data set to detect and address the concept drift over the time. And the fifth one is cross validation. Implement the cross validation technique to assess the model performance on the multiple subsets of data to ensure the robustness against the variations in the data distributions. To overcome the variations in data distributions, we have to apply cross validation. And the sixth one is transfer learning. If possible, apply the leverage the pre-trained models on larger and more diverse data sets to improve the generalization. And by carefully curating and preparing the training data, we can mitigate the impact of non-representative data on your machine learning models. This is very important. And for example, bias, a data set containing mostly one gender, ethnicity, or socio-economic group, it leading to the biased model predictions. So outliers, it includes the extreme or rare cases that don't reflect the typical behavior of the problem. Limited context, using the data from a specific time period that doesn't cover full range of scenarios. Unbalanced classes, having significantly more examples of one class than the other classes, so that causing the model to favor majority. Noise, including the irrelevant features or incorrect data that doesn't contribute to the problem. Sampling bias, collecting data from a specific source that doesn't represent the broader population. Incomplete data, missing information, incomplete records, or gaps that affect the model's ability to learn. So missing information, incomplete records, gaps that affect the model's ability to learn. Thank you for watching our video. In the next video, we are going to see poor quality data. Thank you.